Okay. Now, what is iterated limits? Let S be the any non-empty subset of Rn and let A is equal to A1, A2 belongs to S. That is, the point A lies in S and f is a function from S to R be a scalar field. Okay, S be the non-empty open subset of Rn, that is S be a non-empty subset. The point A belongs to S and f is a function defined from S to R be a scalar field. Then for epsilon greater than 0 and for x belongs to a1 minus epsilon, a1 plus epsilon, that is epsilon neighborhood of a1. For y, limit y tends to a2, f of xy exists and it is equal to g of x. That is limit of the function f of xy when y tends to a2, it is g of x, and if limit x tends to a1, g of x is also exist and it is equal to L. Then we call L is iterated limit. Limit x tends to a1, limit y tends to a2, f of xy is equal to L. Okay. आधी आपण लिमिट कॅल्क्युलेट करताना लिमिट एक्स वाय टेन्स टू 0 एफ ऑफ एक्स वाय इज इक्वल टू असे कॅल्क्युलेट करायचं. आता तसं करणार नाही. आधी आपण लिमिट एक्स टेन्स टू a1, y टेन्स टू a2 असे सेपरेट आउट लिमिट कॅल्क्युलेट करणार आहोत. याच लिमिटला आयट्रेटेड लिमिट असं म्हणतात. म्हणजे त्या त्या इंटरव्हलसाठी ते लिमिट कॅल्क्युलेट केलं जातं. a1 a2 यांच्या नेबरहुडचा विचार करून हे लिमिट कॅल्क्युलेट केलं जातं. x belongs to a1 minus epsilon, a1 plus epsilon. That epsilon neighborhood, the limit of the function f is exists. Okay. For epsilon greater than 0, such that for y belongs to a2 minus epsilon, a2 plus epsilon. That is, y belongs to that neighborhood of a2 neighborhood of epsilon, y belongs to that neighborhood, then limit x tends to a1 f of xy is exist. It is equal to h of y, and limit y tends to a2 h of y is also exist and it is equal to L. Then also limit y tends to a2, limit x tends to a1 f of xy is equal to L. This limit is called as iterated limit. Now how it is calculated iterated limits? Let us see some examples. Okay. Okay. Now, one example is find iterated limit for the following function. Also check whether the function f of xy is continuous at 0, 0. That's we have to not only calculate iterated limit, but also we have to check the function f of xy is continuous at the point 0, 0 or not. Our first example is f of xy is equal to x square y square upon x square plus y square, where xy is not equal to 0, 0. And f of xy is equal to 0 whenever xy is equal to 0. So function is x square y square upon x square plus y square. Okay, so first we calculate iterated limit. Limit x tends to 0, limit y tends to 0, f of xy. Okay, so here limit x tends to 0, limit y tends to 0, f of xy. First we calculate limit y tends to 0 and then limit x tends to 0. Now check limit y tends to 0. If we substitute value of y tends to 0, value of y is equal to 0 in this equation, then we get value of this function is equal to 0. That is, remains only limit x tends to 0, 0 and limit of this function is 0. Okay, now limit y tends to 0, limit x tends to 0, f of xy. That is, first we calculate limit x tends to 0, then limit y tends to 0. So now limit x tends to y tends to 0, limit x tends to 0, that function. Here limit x tends to 0, x tends to 0. Putting x is equal to 0 in this function, we get value is 0. Therefore, limit y tends to 0, 0 is equal to 0. That is, if we first calculate limit y tends to 0, then calculating limit x tends to 0. Otherwise, first calculating limit x tends to 0, then limit y tends to 0. In both the cases, we get the same limit, which is 0. That is, iterated limit of the function is same. Now we have to check the function is continuous or not. So, using definition of continuity. Now remember, what is definition of continuity? We have to check for epsilon greater than 0, there exists delta greater than 0 such that norm of x minus a is less than delta, which implies f of xy minus f of a is less than epsilon. Okay. हे आपल्याला प्रूव्ह करायचं आहे. ओके, सो वी चेक. हॅलो. So we check here for epsilon greater than 0, there exists delta greater than 0 such that norm of xy minus 0, 0 is less than delta. If norm of xy minus 0, 0 is less than delta, by definition of this becomes square root of x square plus y square is less than delta. Then we have to consider the modulus of f of xy minus f of 0, 0. Now, what is value of f of 0, 0? It is 0. So, whenever xy is equal to 0, the function f of 0, 0 is 0. So, remains only f of xy. And the function f of xy is x square y square upon x square plus y square. Okay. So, x square y square upon x square plus y square. All of you know that is mod x is equal to root of x square. Okay. In previous example, we see this condition. Remember? Mod x is equal to square root of x square, and this term is less than or equal to square root of x square plus y square, and which term is less than delta. Means what? Mod x is less than delta. Means x square is less than delta square. Similarly, y square is also less than delta square, and x square y square is less than delta. So delta square into delta square upon delta square. So remains only delta square. So here the delta square here. The delta, which we have to replace this delta square, we have to replace this delta by which number? Epsilon. So therefore choosing delta is equal to square root of epsilon, we get this mod f of xy minus f of 0, 0 is less than epsilon. Therefore f of xy is continuous at 0, 0. So iterated limit of that function is also exist, and both are 0, and the function f of xy is also continuous at that point. Okay, understand? Now next example is consider here f of xy is equal to x square plus y square upon x square minus y square for xy is not equal to 0, 0 otherwise, or 0 otherwise. That is, whenever xy is equal to 0, 0, the function f of xy has value 0. So now first we calculate iterated limit. Iterated limit means first limit x tends to 0, limit y tends to 0, f of xy, and limit y tends to 0, limit x tends to 0, f of xy. So first we calculate limit x tends to 0, limit y tends to 0, that function. Now first limit is limit y tends to 0. So putting value of y is equal to 0 in this equation, y is equal to 0, there remains only x square upon x square, which is x square upon x square, which is 1. That is limit of the function limit x tends to 0 is equal to 1. But limit x tends to 0, it is a scalar, so number is 1. And limit y tends to 0, limit x tends to 0, f of xy. Now first substitute limit x tends to 0. First calculating this limit only. Putting value of x is equal to 0 in this equation, we get here remains only limit y tends to 0, y square upon minus y square, which is equal to minus 1. And limit y tends to 0, minus 1 is equal to minus 1. That is, iterated limits are not same. Okay, now we check the continuity of this function. Here we taking a limit along the path y is equal to mx. To check the continuity of the function, here we take one path y is equal to mx. That is, we substitute y is equal to mx in that function. So consider the function limit xy tends to 0, 0, x square plus value of y is mx. Here also value of y is mx. So x square plus m square x square, x square minus m square x square, taking x square common and we cancel, remains the value 1 plus m square upon 1 minus m square. So value of this limit is 1 plus m square upon 1 minus m square. So value of limit is different for different values of m. Okay, if value of m changes, then value of limit is also changes. Therefore, limit is not unique, and limit is not unique. Therefore, limit does not exist, and therefore this function is not continuous. So in this case, we get iterated limit are also not same, and the function is also not continuous at point 0, 0. Okay, write later. Okay.